All right, good morning, everybody. We're going to do a lesson today on line segments and distance. And I will tell you, before you even start to try to do this lesson, you got to make sure you have a pretty good grasp of Pythagorean theorem. Yeah? You have to understand Pythagorean theorem because a lot of this will not make sense without it. All right? We'll get into some of the easy parts and then we'll get into the harder part afterwards. I'm going to do example 1 and 2 first. But let's first get a definition out of the way. A line segment is like a line, okay? And what was my way of visualizing what a line is? When I said a line, picture it as awkward silence, sad. An infinite amount of string, yeah? It's a string that just goes in both directions forever. Easy enough? What's a line segment? Part of it, cutting the string at two places and holding it. That's a line segment. They have a different symbol. Notice what's not above it now. If I say segment FG or GH, what am I saying? What's different there than what we've done before? There's no arrow. So that's how you do segments, so be careful with it. We typically are talking about segments in math, in geometry, but sometimes it'll be about the entire line, okay? That's just line segment, okay? And then we got a really complicated theorem. Yes? It says a segment addition postulate. You ready? What it says? The whole thing is equal to the two parts added together. That's all it's saying. Yeah? The whole thing, FH, is equal to what? FG plus GH. That's it. Is that hard? No. Okay. All right, we're going to skip that next part because I want to do this first. I think there's a typo here. Let me give you some advice when you're doing these tonight. Don't come asking me for help or anything until you've drawn a picture of it. Draw a picture first, then ask for help. Okay? So let's draw a picture of it. What do we know? Find the value of the given point B is between C and D. So what do we know? Where's B? Where's B? Somewhere in between. I don't know where, but I'm just going to say there's my line segment and B's somewhere. I'm just going to put it here. I don't know where it is, but I know it's between them. You with me on that? Okay. All right, start filling in what I know. What do I know? So this is 2x. What else do I know? Is 4x. And what else do I know? The whole thing is... So do some kind of picture like that, yeah? Is that hard? Is that hard? No. Now what? Okay, how would I solve it? Well, the segment addition theorem, right. The segment addition theorem says the two pieces add up to the whole, right? So what's my first piece? I mean, if you want to write this in your notes the first time, you would say CB plus BD is equal to what? You don't have to write this on your homework tonight, but I'm just doing it on notes, yeah? Is equal to CD. That's the segment addition theorem, right? And then what are the pieces? 2x plus is equal to 12. And then you do this thing called algebra. You get 6x equals 12, so x is 2. So x is 2. What's CB? What'd you do? 2 times whatever x is. So that's 4. And what's BD? 8. And guess what 4 plus 8 is? What I needed. Is that hard? You will find in geometry, and I think this is true more than it's not the geometry that gets in the way. It's people suck at algebra, and because they suck at algebra, they think they suck at geometry. But it really goes back to the algebra that they're bad at. If you understand algebra, geometry typically is pretty easy, okay? I think there's a typo in the next one. Let me make sure. CB and CD. I gotta be careful here because I think this thing goes negative if I'm not mistaken. Because if I add those, it goes negative. Wait, they both go negative. I think I might have to change this one, but I think we might be okay. Every year I do this one and all right, what do I know? Well, I know it's the same as before, C, B, and D, right? Somewhere. I know CB is 4x plus 9. I know CD is what? 8x plus 5, right? That might be wrong.
Yeah, ours is -9 -5.
Oh, so yours is different from mine? So I just never fixed mine? I think I fixed it on your notes, which is nice. Okay, so that's what we're saying? Watch this fix not work either. So let's see if I'm right. So -9 and the whole thing is -5, you said? Okay. And what do we got? BD is, and BD is 2x plus 20. We're okay with that one? Okay. All right, so what do we know? We know that I should have given us... That's interesting. Let me do this. So it's going to be 6x minus something. Now plus. Yeah, I think this. Write that. Go ahead and fill that out. I think that'll work. Watch, it doesn't. I swear it never works. 15. Yeah, I think we're okay. Okay. The number might be ugly, but it's going to work, I think. All right. Okay, what do we know? That CB plus BD must equal the whole thing. Agreed? I'm not going to go through all that, but what do we know? We know that 4x minus 9 plus 2x plus 20 equals what? 8x minus 5. Listen, we can do the algebra quickly now. I don't mind if you do multiple steps at once. We'll move things from the left and the right at the same time. So what am I going to do? What is that? 6x what? Plus 11 is equal to 8x minus 5. All right, I'm going to bring the 5. Watch what I'm going to do. I'm going to bring the 5 over to the left, and I'm going to bring the 6x to the right. I'm not going to show this step. We're at the point now in algebra that you should be able to do that step in your head. Bring the 6x over. What happens on the right side? If I bring the 6x over, it becomes 2x, right? If I bring the 5 over, it becomes what? 16. If you need to do that in 2 steps, then do it in 2 steps. I don't have a problem with that, okay? And then what is x then? 8. X is 8. So x is 8. All right. What is CB? Well, what would I do? Well, it's 4x minus 9, right? So it'd be 4 times 8 minus 9 is what? 23. All right. And BD would be what? 2 times 8 is 16 plus 20, so 36. Agreed? Yes? And you can check it. If you add up all the numbers, right, if you do each section and add it together, it should add up to the whole thing, which is whatever CD is, right? Let's see, what would that be? 64 minus 5, so 59. The whole thing should add up to 59? Is this hard? Okay. All right. Put everything down for a few minutes and just pay attention here. Math team, you already know a little bit about this, a lot about this, okay? All right. The next thing we're going to talk about is we got to give ourselves some context here. All right, if we go from 0 to 12, how long is this segment? 12. It's 12. Yay. What if this was 7 and this was, like, say, 20? Now, I could sit there and think of a way to count it out. I could count from 7 to 20 to figure out how far I went, but there's a better way to do it. Anybody? If you subtract them. If you subtract 20 minus 7, it tells you how far you moved, right? So 20 minus 7 is what? 13. Okay, I need you to get this stuck in your head. This distance is 13 then, right? I need you to get this stuck in your head. When you see a formula in geometry or real life, when you're subtracting in a formula, you're usually finding distance. Now, what if you did 7 minus 20 by accident? You'd get negative 13, but distance can't be negative, right? If I have one friend who lives 13 miles that way and I have another friend who lives 13 miles that way, which one lives negative 13 miles away? Neither. Distance is always positive, yeah? It's like absolute value if you want to get into the math, right? So if you ever do subtract and you get a negative, just understand that it's actually the positive version of that. Easy enough? that hard? All right. So to find distance between 2 points, what do? Subtract. So watch this. What if it was at negative 12? This is a harder one, to 15. The first mistake people make is 3, and then I would say you're drunk. That is a little bit more than 3, I'm pretty sure. What can you do? 15 minus negative 12, which is 27. Another way to visualize it, the way I typically will do it, is also like, how far does negative 12 need to get to 0? And then how much more to get to 15? 15. Oh, so 27. That's usually the way I visualize it. Is that hard? Is that hard? Okay. Ooh, what if they were like this, though? What if this was 28 and this was negative 3? And I asked you how far that was. Would it matter if it was up and down or left and right? What would you do? 28 minus 3, right? No. Minus negative 3. Right? Which is? And the reason that works is minusing a negative 3 is really 28 plus 3, and you can visualize that, right? It takes you 3 to get to 0, and then it takes you another 28 to get to 28. Logical? Do you need a formula for that? No. Use your brain. Okay. Math team, be quiet here. The next place we're going to go is, what if I have a point here, and I have a point here? What's the most obvious question they could ask you about those 2 points? Well, points don't meet. Points are sitting there. So what do you think? What about, there's a line segment there. What do you think they would ask you about the line segment? How long is it? Yeah? Well, let's see if we can figure out a way to do this. And there's a very easy way to do this, okay? You don't need a formula for it. Yeah? Here's what you do. You see how you have those 2 points? What you can do is you can sketch out a right triangle. And it doesn't matter where the 2 points are, right? If I have the graph over here and the points here and here, look what I can do. See it? If I ever have 2 points, it always makes a right triangle, no matter where they are. Does it make sense? So what can I do? Well, I can use, how about I find this distance if I turn it into a right triangle? Pythagorean theorem. I would say, how long is this? 3. How long is this? 4. Oh. Come on. 3, 4, 5. So this is a distance of 5, yes? All right. So what if I did this? We're not writing right now. We're just paying attention, right? So what if I gave you this one? Okay, what if I have these 2 points here? Yeah? I have those 2 points there. Yeah? This point is at what? What is that? 1, 2, 3, 4, 5, 6, 7. 7, 3. And where's that point at? Negative 5, negative 2, I believe. Agreed? Okay. On our homework tonight, you must do it this way. All right? What I want you to do is sketch out the triangle. You can just make a 2-second version of it. I don't care. It doesn't have to be perfect. And then what we're going to do is determine this distance. Yeah? What part of that coordinate determines this distance? The x coordinate or the y coordinate? The x, because that's here's the negative 5, right? And it goes to what? 7? So if I'm going from negative 5 to 7, how far did I move? 2. No. How far? No. 12. I want a distance of 12. I can visualize this pretty easily, right? I can say to get from negative 5 to 0, how far do I have to move? And then 7 more, which would make a distance of 12. So I now know that this is 12, yeah? You with me? And then what am I doing? I'm going from here to here, which is what? That's 3 to what? Negative 2. How far? That's a distance of 5. Could I find that 5 another way? Sure, I could have done what? 3 minus a negative 2, right? Which would have been what? 5. And I could have done what? 7 minus a negative 5, and I would have gotten 12. Yes? Why does subtraction work? When you subtract two numbers, you find distance between them. Easy enough? All right. So 5 and 12. So what's the distance? 5, 12, 13. That distance is 13. Is that hard? If you don't like that method, you could do this. Distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. That's easy, huh? No. If you look at this formula, you'll almost never see me write it. Let's think this through for a minute. Okay, so I gave you a hint earlier. What is this telling me? I want math team to be quiet, new people. Come on, if I subtract two things, distance. This is finding the distance between the what? The x's. What's this doing? That's the distance between the y's. Why am I squaring them? C squared is equal to a squared plus b squared. Remember that? So if you square root and square root, whoa, this is looking like this, isn't it? What's the a represent? The distance between the x's. Why am I squaring it? Pythagorean theorem says to square it. When we get later in the year, I'll show you the proof behind why Pythagorean theorem works, yeah? But it's really about areas, yeah? Why am I squaring this? I'm finding the distance between the x's, and I'm squaring it because that's Pythagorean theorem. Same thing with the y's. Why am I adding it? Oh my goodness. Because of Pythagorean theorem. This entire formula right here is just Pythagorean theorem, where the d ends up being the c. The distance ends up being the hypotenuse, which is what we were doing up here, right? This distance right here was just the hypotenuse, right? Which was the c number, which is also the distance. You get what I'm doing here? Is that a new formula, really? No. That is an overly complicated way of doing Pythagorean theorem. It's way easier to just look at it and find the triple. Does that make sense? What's the formula saying? Well, find out how far between the x's. Well, how do I find out how far between the x's? I subtract them. I square it because it's a squared. Plus, I find the distance between the y's squared, and then I square root it because that would be what d was, not what d squared was. Does that make sense? I don't want you doing this. I want you doing this, making quick little sketches of it, and it can be a 2-second sketch. And what are you looking for? Triples. If you can't find a triple, then you have to do the math. You with me on that? All right, so let's try one. Oh. All right, here we go. All right, so what we're going to do is we're going to make a 2-second sketch of this, right? We're going to say, here's my coordinate plane, here's A, and then, I don't know, 6, 8 is over here, here's B. That's at 0, 0, and that's at 6, 8. You don't have to be exact, but there's my picture, right? See it? Do something like that. Is that hard? No. Okay, what do I do? I need to find the distance between the x's, right? How long is that side? 6. So it's going to be a 6 something. How far between the y's? 8. I could do that, right? If I wanted to follow the formula, I could say the distance, we're going to do it both ways. The distance is equal to the square root of how far between the x's? 6 squared plus how far between the y's? 8 squared. Now, I'd rather use this because I know my triples. That's a triple we should know. 6, 8, 10 is really? That's really a 3, 4, 5 dilated times 2. So if it's a 3, 4, 5, then that's really 10. So you get the distance is 10. You can go and do Pythagorean theorem if you want. right? 6 squared plus 8 squared, what is that? 36 plus 64, which I think is 100. Square root of that'd be the square root of 100, which is 10. I mean, technically plus or minus 10, but you can't have negative distance, so you ignore that one. Yeah? Is this hard? All right. Do I need this formula? Do I need that formula? No. What is that? That's just finding the distance. In fact, if I wanted to fix this formula, the distance between the x's squared plus the distance between the y squared. That's it. That's what that whole thing is saying. All right, let's do it again. How do we start these off, everybody? Sketch it. So I'm going to make a 2-second sketch of it, yeah? Let's see, negative 2, 3. There's R. And then what? 350. Wait, that's right. Way up here somewhere, right? That's 315 up here. That's S. And this is what? Negative 2, 3. You'll have more room on your homework, so blunk. There's my triangle. Let me start showing you a shortcut you can do. You ready? To find this distance, I focus in on this number and this number, yeah? Focus in on those two numbers. So how far from negative 2 to 3?
5.
As soon as I see 5, what's my brain thinking? Nope, because 5 would have to be the hypotenuse. 5, 12, 13. I bet you this is going to be 12. Let's see. What do I focus in on if I want to do the how far between the y's? I focus in on this and this. Make sense? So for the x's, I focus in on these two for the x, and I focus in on these two for the y. You get it? Okay, how far is it from 5 to 15? I'm sorry, 3 to 15? 12. So that's a distance of 12. Then I would just say what? 5, 12, 13. So the distance is a distance of 13. If it's a triple, you know you're done easily, yeah? All right, next one. Sketch it out again. What is that? 11, negative 12 is way down here, right? That's C. I'm not going to do all three of these. 11, negative 12, and then 6, 2. 6, 2 is D. 6, 2. There's my triangle. And listen, it doesn't matter if you sketch your triangle like this or like this, you still get the same thing. You pick. It doesn't really matter, okay? All right. We're going to find this first. What is this distance? Somebody help me out. What do I focus in on if I want to find that distance? The x's, right? How far from 11 to 6? 5. What's my brain thinking? 5, 12, 13. All right, it's not going to work this time. How far between the y's? What do I focus in on? The y numbers. How far from negative 12 to 2? 14. So this is 14, yes? The 5, 14, what triangle? Right. Okay. So once it doesn't work, I don't know a triple for that. There's no 5, 14 anything. What I can do is I know the distance is equal to the square root of what? How far between the x's? How far? 5 squared. Plus, how far between the y's? 14 squared. And from there, you can use a calculator, all right? You're going to need to write it two ways tonight. You're going to have to write it as a, no, let's just write it out like that, and then when you get down to the end, write it as an estimated decimal. Whatever they tell you to round to. I don't know what they're going to tell you to round to tonight. They don't even tell you. Go to 1 decimal place, yeah? The nearest tenth, yeah? All right, so what is this? 25 plus? Come on, Matthew. 196. So we got 25 plus 196, which is what, somebody? So we get the distance is the square root of 221. What's the square root of 221? Any number? No. So that's where you're going to have to approximate it. So grab a calculator and just approximate it, right? 221 square rooted is around 14.9. A distance of around 14.9. Easy? All right. That's the easy part. All right, we are going to do a couple more examples. No, we're going to actually stop there tonight. That's where we're going to stop. Yeah, that's where we're stopping tonight. All right. Line segments and distance.